Good morning everybody and welcome to another 1 hour build. As you know, I will be doing rock, paper, scissors again because there's still quite a lot of depth in there. So 1 hour build, rock, paper, scissors. And this time I'd like to try something a little bit different. I'd like to experiment with test-driven development. I know that it can be a little bit controversial, especially in prototyping, but I just want to find out whether it helps or hinders my development speed. So let's start off with defining a test module. We'll use XUnit, and there's a trick that we need to do to actually make it work in Livebook, which is turn off auto start, set that to false, and then when you xunit.run, and in here we define our module, and that's gonna be RPS test, and we need to use xunit.case, and we need to turn off async, and now we can start writing some tests. So we can do test dummy assert true. So now we should have one passing test. There we go. Cool. Okay. So the first thing we actually want to implement is functionality. I think we're going to build from the inside out this time, largely because this way of testing doesn't actually allow us to test buttons and other UI elements that are built with Kino. I spoke to some of the team yesterday, and it is something they're considering, but and there are some ways around it. But for now, in the interest of time, we're just going to test the backend logic, as it were. So we're going to describe what happens when you do. In fact, let's change this. We're not going to test our whole thing. Our first module is going to be a round, and we're going to describe the core judge functionality of that round, and we're going to test a same option draw. So this is when all the choices of the players in the round are the same. So rock, paper, paper, scissors, scissors, so on and so forth. So assert, and we're going to call round.judge, and we're going to pass an array of chosen options. So for example, just rock in this case. Now, obviously this is going to fail, but we've got our failing test. One passes, and then the modules are undefined and the function is undefined. So let's start by defining that. If module round do, and then we can run again. We can set this to evaluate automatically. And yep, that fails again because round.judge is undefined. So def judge. And it'll take an array of anything, and it'll return. Oh, we need to actually set an assertion here. So assert returns a draw, and that should return a draw as well. Cool. So that passes. Now, I would like to make sure. In fact, let's put rock in there. So that passes, and I want to randomize what the option is to make sure that it works for all of them. So if we do an options array of rock, paper, scissors, and then what we can do is here, we can pick a random one from them. Not random. That's interesting. Why does that happen? That should fail. Let's check this out. So if we set paper, there shouldn't be a clause that matches paper. Yeah. So why does that one pass? Oh, because the seed's the same. Why is the seed the same? That's really not very useful. Lifebook X unit random seed always the same. Okay, it's fine. We can just work around that. So what we're gonna do is we are going to test all three of them. So that's gonna be a rock, and that's gonna be scissors. That's a bit annoying, that. But either way, so what we can do is if we put an underscore there, it means we don't care about the value. We're just pattern matching on a single element array. Then that should make all those tests pass. Yep. Okay. And I suppose we probably don't need this anymore. But okay. So the other case, annoyingly, we do. The other case is you can get a draw when you have more than 2 players and at least one player has chosen each option. So all options draw. And this essentially sets us up for being able to have more than 2 players in a round. So again, we can assert round.judge, and in this case we're going to have rock. In fact, what we're going to have is our options, all the options, and that should also be a draw. Now obviously that's not going to work. We've got our failing test, and we've got rock, paper, scissors. So we can do def judge rock, paper, scissors, and we can do draw. And now if we run that, our test pass. But we have a slight problem, which is that if we get these options in a different order, so for example, let's copy that, and in fact we can just pass it to sort. And we run it again. That now fails because we have a clause for rock, paper, scissors, but we've gotten paper, rock, scissors. So we have a couple of options here. One is we either implement a clause for every possible permutation, or and continue that approach with all the other clauses we need to implement for the wins, or we implement a contract that says the the choices array must always be sorted, which then means we don't have to implement the other clauses. And personally, I know which I prefer, especially in the interest of time. So we're going to copy this sorted list, and we're going to put it in here. And now one of them will pass and the other one, rock, paper, scissors, will fail, which is fine. We can do that. And that can be, we can add a doc and just say note traces array input must be sorted, and I'll put that at the top here because it really should apply to all the clauses. And so now we can we've got handling for all the draw situations. We can test rock wins. So we can do assert round.judge, and we are going to give it rock, comma scissors, and we're going to expect the result to be rock. So this function obviously takes a set of inputs and returns the winning choice. So def judge, in fact we can do that, takes a list of choices and returns the winning one or draw. So if we had to go here and we do rock, comma paper, no, rock, comma scissors, then we will get a do rock. And there we go. Now that passes. Cool. So we want basically the same thing again. And because this array, because we expect these in sorted order, we only need one implementation because rock comes before scissors, alphabetically sorted. So we don't have to have the opposite permutation, which makes our lives a little bit easier. So paper wins, so rock, paper, and that fails. Def judge rock, paper, do paper, and that now passes. Awesome. Right, and we can do scissors wins. So we have paper, scissors, and returns scissors. And now that will fail. And we def judge paper, comma scissors, do scissors. We'll run it again, and the test has passed. Awesome. I wonder actually if I can. I can't because it's. I wonder if I put this in a section. Tests. Can I collapse the session? No, if I collapse the section, then I can't see the results at all. That's a bit annoying. But it's fine. Right, so we have all our main cases handled, but what we don't have handled is test unsorted list. So, for example, we can grab that assertion there, and we can give it scissors, comma paper, and that will fail. Which, like, yeah, we can sort it through a contract, but what might be a bit easier or nicer as a user is to define a function here, judge, which just takes a list with multiple elements, in fact any list, and let's call that choices. And what we're going to do is we're going to take the choices and we are going to first of all make sure they're unique, because we need that. And in fact we can that's a separate test. Let's not worry about that for now. And we can do enum.sort and then pass that into judge, and that should make that test pass. Awesome. And that should work with any permutation. So if we copy that, we should be able to do paper rock and scissors rock, and that should give us paper and rock. And also we should be able to do the same thing with our unsorted array of at options. Okay, so we've introduced an infinite loop here. Why? We do call judge, but it should always hit one of those options. Let's just debug. Oh, it's because we haven't actually saved that function yet. No. Paper rock. We get paper and rock. And then what do we send into judge? Line 14. Oh, yes. Yeah, paper comes first, because it turns out I don't know my alphabet. Let's try that. Actually complete. Yes, it did. Cool. Okay, so let's get rid of that debug. Get rid of that debug. And our tests are failing because when we get all the options, yeah, that should be a draw. Cool. Awesome. So that works. What doesn't work is if we copy that and we use here scissors. Should have chosen a shorter one. We don't have a matching clause for this, and because we don't have matching clause and judge calls itself recursively, we end up in an infinite loop. So then we introduce our unique constraint here, and then we can run our tests again and they pass. Cool. Okay, so that is the core of our judge functionality. And we can get rid of this note now because we do the sorting and we don't care what order they come in. Now, this gives us the winning choice, but we still need to declare a winning player or players out of once we have that choice. So let's start describing our new functionality here. So we can describe declare winners and we're going to have a test, and what will this test do? We want to say let's have a look. All players returned when if not a draw. Because essentially what a round does, and we can make a note of this at doc. Essentially, it takes a list of players. There will be a process soon, but takes a list of players, prompts for choices, and returns a list of remaining players. So if you've got 2 players go in, you get a draw, then 2 players come out. If you have 2 players go in and you get a draw, you get a win, then 1 player comes out. So what we can do is we can do round dot declare, and we want declare needs to know. It needs to know the players, which is going to be a list. It can just be Bob, Alice, and it needs to know their choices. And I think it's actually going to be easier to make this a map with their choices. So for example, for a draw, we can do rock, and we can put them both in there, Bob, Alice. Doesn't need to know anything else. What might be useful actually is a track of pending, and this is just a list of players who have yet to make their choice. Remaining players. And then we can assert that remaining players is equal to Bob, and Alice. So we can run this, and why is this there? Yeah, that's weird. Okay, doesn't matter. Okay, trying to call with declare, which is undefined or private. Let's fix that. So we can collapse this, and we can run def declare, and this is going to take players players, pending, choices, and we know that that's going to be a, actually it doesn't really matter. For now we can just do it like that, and just save it. We get a bunch of warnings and then we get errors because choices, rock, paper, scissors, no. What, pending is in choices? Yes, it is. So it is. Right, let's try that again. Yeah, so it returns now. So, what we need to, in fact, we can satisfy that test very stupidly by returning players. And now our test passes, even though it doesn't, our function doesn't do anything. But we start adding more functionality and more assertions, and that will work. So we can test only players with a winning choice returned. If not a draw. Okay, so we're gonna have basically a lot of this, but what we're gonna do is we're gonna move Alice. Alice is still gonna be a player. We're gonna move Alice into a paper choice, and then let's run that and see what happens. And yeah, that means that if Alice chose paper, then only Alice survives. Bob loses. Okay, so now what we need to do is we need to do winning choice is equal to judge. And then what we need to do is we have two lots of choices here. So we need to grab the values. Now we need to grab the keys. So we can do choices and pipe that into map.keys, I think. Yeah. And that should give us a winning choice. And then we can just return choices at winning choice. Okay, so our not a draw test passes, but our old test now doesn't, because when it's a draw, so what we can do is we can pass that into a conditional, and we can say when it's draw, we return players, otherwise we return choices at winning choice. But we won't have that, so what we can do is winning choice comes in here. Case how's okay. Right. And now that passes, cool. So that works. Now we are keeping track of pending players, which means we can't, and the reason I've added that in is we don't want to declare a winner before all the players have made their choice or been eliminated in some way. So test, we want to say doesn't declare a winner before all players have played. So what we want to do, again, we'll grab a lot of this and then modify it, and we will say we've got players Bob and Alice, and in here we're gonna have Bob make a choice, and then we're gonna have Alice be pending, and we can save that as declaration. And that should say something like waiting for player choices. And of course that's going to fail. Because at the moment we don't care about pending. So what we're going to do is we're going to set a when length of pending is equal to 0. Okay, and that will now fail because there's no matching clause. And what we can do is we can add a clause that says, so we're going to put this clause second, and it's basically going to be the same thing. In fact, I'm just going to copy that. And we don't care about anything other, well, in fact, we don't care about anything here, because we know that the only thing we can return is do waiting for player choices. So the reason we don't care about what we get is we're not going to use the players, we're not going to use the choices. We know that pending length is greater than 1, because otherwise the previous clause would have been selected. So we just return our thing. And cool, that passes. So we're making some progress. We can now declare winners, but we can't actually play and make choices. So the next thing we're going to do is start playing the game. So describe play, and this is going to be the functionality that a user interacts with, well, eventually. So test what needs to happen here. What do we want to test? Yes, so we want to test that when a user makes a choice, that the choice is recorded. Choices are recorded. So what we want to do now, for this, I think we will need to turn our round module into a gen server, and do round is equal gen server dot start link, and it's going to be round, and we're going to start it with a list of players. So Bob and, why do I say Bob and Alice and not Alice and Bob? Anyway, and we're gonna call it test round. So we're going to get round, and this is going to fail already because there's no start link. But all we need to do is we can use def. No, we can use gen server. I believe that will require us to. Okay, no, that will inject an init. That's awesome. So, yeah, that passes. Okay, so next thing we want to do is we want to do round dot play, and we're gonna give it a player. We're going to give it a choice. Interesting. I think we might also need the name of a round here. Unless we always call the round the same thing. Let's keep it simple for now and not name a round. Name them round. And then that will fail. And actually this will return okay, comma, round bit. Okay, sorry, so that will be Bob, and the choice will be paper. Okay, and that will fail because round play is not defined. Right, so let's define that. Def play, and it'll get a player, and it'll get a choice. Now, the interesting thing here is that we can't actually do anything in this function because we don't have access to the players array, we don't have access to the choices, we don't have access to anything. So what we need to do is we need to actually do a gen server call. And that will trigger the gen server. We'll call to ourselves, and the request will be play, and we will have the player and the choice, and that should be fine. Which means when we call that, we will get another error because no handle call was provided. So let's do that. We can do def. In fact, there'll be an implementation of gen server, and we can do def handle call. And when we handle a call, we get an array of things. So that will be play, player, and choice, and then we get our from, and then we get a state. And we want to return a reply. We'll return something here, which is hopefully going to be okay. And in fact, I'm going to just call that result, and I'm going to get a state. So what we need to do is we take our play and we add it to the choices array, or the choices map actually. So we need to grab that from there. So choices is choices. Let's just make result. Okay, and see how that plays out. That is going to play Bob paper. Is that in round handle call? Yes, because the state doesn't match now. So we are going to implement gen server, and we're going to define an init function. And the init function is going to take a list, and in fact, yeah, a list. Yeah, just take any list, players, and we're gonna do when length of players is greater than 1, just so that we've got that safety there. And what we need to do is return an OK, and we're going to return a new state, which is going to be a map. The map will have players is players, and it'll have choices, which is going to be an empty map. And it should also have pending, but for now we might not care. So let's see. Now let's just put it in there. And it'll be the same as players, because all players start off in a waiting for choice state. So now I'm running again. Need a comma there, and they're unused, but that should be happy. Cool. Okay, so round pid is unused. I think, does that get, yeah, that gets automatically shut down, because otherwise we wouldn't be able to run them. So we actually don't care about that. So Bob will play, and then actually what we want to do is check the state. So we're gonna introduce a utility function to do round.state. And what we're going to assert is that state is equal to, and that will have choices, and the choices will have a paper clause, a paper key, and in there we will have Bob. So obviously state is undefined, so we're going to define here def state, takes no arguments, do, and it does a gen server dot call to itself and provides just state as a key. And you do def handle. We don't need the impl here because we've got it up above for the same clause, for the clause above, and that applies to all of them. And we're going to do state from state, and that's going to do return reply state, and leave the state unchanged. Now, so where are we? Cool. Okay, so we can do state of choices is equal to, because I was trying to pattern match in an assert. Yeah, and we can see it's failed because we haven't actually added Bob's choice to the choice map. So what we can do is state, and we pass the state is equal to state, and then we'll pass that into map.update, and we're going to update choices, and we're going to pass that. Oh, hold on. So we'll need a function here. Then choices, and what we're going to do to choices is we're going to do masking that result, but I don't think it matters. Because it is the same thing, and we're going to put that into map dot put. Now it needs to be update 4, I think. So we've got our map first. Our key is going to be the choice. Our default value. And the default value won't be passed through the update function, right? So our default value will be an array with the player in there. And if there are already players, then we're going to have a function of players and what we're going to do is just put our player at the start of the players array, a list, and that should do the trick for us. Let's see, where are we? Yep, that's passing. Cool. Now what do we have squigglies for? Choices is unused. Interesting. That's fine. We can check that. So we have the core of that functionality. We can add some additional test cases. So, what else do we want to check? We want to check that a player who isn't in the round can't play. So, only registered players can play. So, again, we're going to do that. I wonder if that's going to be an issue. In fact, I'm just going to start that. No, it's not. The testing are independent. Cool. And that's probably because we have async false. And we're going to do basically all of this. But what we're going to do is, instead of Bob playing, we're going to have Charlie playing. And then we're going to check the state, and the state choices should be an empty map. And also the result here. Result should be assert state assert result is equal to invalid player. Okay, so let's have a look. So here we do need participants. No, we need pending, sorry. And what we're gonna do is we're gonna grab result, state, and we're gonna put this in a conditional to if enum.member, and we're going to check pending, and we're going to check player. Now the interesting thing is pending will, I think, Maybe what we do is we just return a generic not allowed rather than invalid player, not allowed. And then what we can do is we can just use the pending list. So if they're a member of the pending list, then we do basically all of this. So result's going to be okay, state's going to be that, and then we return result, comma, state. Else, if they're not a member of the pending list, then we return not allowed, comma, state. Now the other thing we need to make sure is that players are actually removed from the pending list. So map.update, and we're going to update pending. I'm going to take a function that has players and that's going to be a list. So we're going to have players and we're going to do enum.pop. I think the list actually list.pop. No. Key member, key sort, no. Place at delete. There we go. We want to delete, and we want to delete player from that list. So we can check, for example, we can have an additional assertion here. In fact, let's not do that. Let's get the test in to make sure it's in, and then we'll do it. So take this bit, comment it out, and what we're going to do is assert state.pending is equal to Alice. And we can assert here that state.pending is equal to Bob and Alice. Right, and that's going to fail because that state.pending doesn't get updated. So then we do this, and they both pass. Cool. And that will now complain because choices is unused. Do we not need choices? We don't, because we grab it from the state. So, and do we need pending? Probably don't need pending either because we grab it from the choice. From the, yeah. Oh no, we do need pending. Okay, cool. So, it is now possible to play a game. Now, how do we trigger when there are no more pending players? Do we automatically trigger a result? Or do we just check for winners? Let's see, we should be able to use what we've got now to actually have a full game. So test, in fact that can be describe round 2, and we can do test full round And what we can do is we will set up a round. This can be our end-to-end test actually for that functionality, or a flow test. So we have Bob and Alice in the round. We want Bob to play paper. We want Alice to also play paper. And then we want to assert state. We can see state will have paper and an array with Bob and Alice there, which we're just going to grab from here. Pending will be an empty list, and then we can don't need to save the result now. That result is not right. Don't need that. Don't need that. But what we do need is declaration is equal to round dot declare. Does it take an argument? I don't think it does it? Oh yeah, because it needs the state. Needs that information. But what we can do actually is we can just pass the state in there. And we can assert declaration is equal to, and there should just be Bob and Alice there. Okay, wrong order, but that is fine. It makes sense, yeah, right? Because Alice plays second, so if we actually make Alice play first, then that should work. Yep, all test pass. Oh, yes, cool. So full round draw, and let's get another one to make sure that we can actually get a winner. So again, Alice and Bob, but in this case, Alice will choose scissors. So we'll take her out of that list, and we'll add another one saying scissors, and we will put Alice in there. Well, there should still be none pending, and then the declaration should just be Alice is the glorious winner. Yes. So that works. Okay. Well, test driven. We have a round. We have perhaps, I hope, I dare say, more confidence in the implementation. There are still a few missing bits in terms of how that the declaration function is called. I'm tempted to do another call. Well, I can't do a call, but I can do a cast probably. After a player plays, maybe, or maybe we can have a function that just periodically checks, and when there are no pending choices, then it automatically declares the round. But I think for now we are at a reasonably good stopping point. Cool. Thank you very much. Bye.